Okay, yeah, welcome everyone for the next session here. And I would like to welcome Matthias Palmersheim. And you know, I'm from Germany, so I can perfectly pronounce his name. That's some advantage. So Matthias is going to talk about how to use AI assistance with your monitoring system. I'm really excited for this one. And yeah, welcome, Matthias.
Thanks. As you said, I'm Matthias Palmersheim. I'm a solutions engineer at Victoria Metrics, where I help our open source users and community members to get the most out of their observability system. And in my spare time, I maintain a project called Shiftmon, which tries to create an opinionated observability stack so you can have good observability, but you don't need a massive K8s cluster or a really expensive SaaS bill. And when I'm not sitting in front of a computer, I like training Brazilian Jiu-Jitsu. And if you want to see anything I'm doing at Victoria Metrics with Shiftmon or anything, you can either scan this QR code or go to links.shiftsystems.net, and that'll have Matrix ID, LinkedIn, all that good stuff. So what is MCP and how does it work? MCP is short for Model Context Protocol, which is an open standard that describes a way for AI agents and applications to talk to external data sources and external tools. So this could be talking to like a SQL database or running shell commands on your behalf from your machine. And it was introduced by Anthropic in November of last year. Oh no, lag. And the high-level way to think about MCP is you can think about it like the USB-C port for AI agents. So before we had USB-C on laptops ubiquitously, you had different connectors for networking, different connectors for random peripherals, and different connectors for display. But now, even if the dongle looks a little bit goofy, you can get a USB-C connector for pretty much everything now. And so what this looks like in practice is we'll have some chat interface or agent software, and then we'll have external services or tools that we'll want to have access to. And then you'll prompt the tool to say something like, tell me about the current firing alerts, or tell me about this metric. It'll do some thinking. It'll reach out to your metric solution and then give you a response based on that tool. But how does that connection work? So the chat software is going to be made up of a couple of different parts. The first one is going to be an LLM, or large language model. So an LLM is a form of artificial intelligence that gets fed a whole bunch of text and then trains on that text and then learns to predict, based on its training data and any other context it has, what the next response or what the next token in the response should be. So that's how the LLM works. But then how do we get the LLM to communicate to all those external services? Before MCP, it was an M times N problem, where every different model you were interacting with and every different tool had their own connection. So the complexity you had to deal with was the product of the number of external integrations you wanted to have times the number of models you wanted to integrate with, which could be extremely challenging because even if you just support we'll just say 5 different models from different vendors and 2 tools, that's 10 different combinations you would have to support, and that problem gets out of control pretty quick. So what we did was we made a standard for interacting with external tools called MCP. So now you would just have an MCP server that would connect to each individual source, and then the chat application would just be able to interact with that over a standard protocol. So the MCP client would live inside of the chat app or whatever agent you're using and then speak to the MCP servers in order to access the external tools. And what an MCP server is it's a program that provides tools, resources, and template prompts to a chat application. So tools would be things like asking about metrics in a database, running commands, or accessing any API. You could also give it resources. So a lot of models will get trained, and if you ask when were you trained, you'll notice it'll be like a year in the past. And so if you're working on a solution that's changing rather quickly, you would need to feed it documentation or more up-to-date resources for your solution, and that's what the Victoria Metrics MCP does. It can give your AI agent access to up-to-date documentation. And then for helping to get started, you could also provide it prompts and templates so that way it's easier to get started with using. And because there's so many different MCP servers, because MCP is so popular right now, there's a whole bunch of different ways where if you just have an open API spec, you can wrap that as an MCP server pretty quickly. So that's how the server side works, and then the client lives inside of the chat application, and then it will communicate with the LLM to get a response. And the way that communication works is that the query will be ingested into the application, and then it will communicate with the LLM to say, hey, here's the prompt. Do you have any tools that you think would be helpful for this? The LLM responds yes. It will tell the MCP client to go reach out to those MCP servers, execute a tool call, and then that response is structured in a way that the LLM can understand it and add it to its context and augment the response. So that combination of the MCP client and LLM are going to be the main building blocks of the agent, and they can be used for autonomous software development, or you could have it complete tools and tasks on themselves. And something that's becoming more common and was mentioned in the last talk was that AI agents don't live in a isolated vacuum anymore. Agents are constantly working together to go through flows. The most common flow being you would have one agent writing a test and then another agent validating that test, and if it fails, it will send the output and what went wrong to the previous agent, and that loop will continue until the test succeeds. Sorry about that. So a bit more specific now, we're going to talk about the Victoria Metrics MCP server. You can find the GitHub repo at the QR code on screen, and it is permissively licensed, and it can be accessed a ton of different ways. So you can grab it from the GitHub container registry. If you have the Go tool chain installed on your machine, you can grab it with GoGet. You can build it from source. Or we also have GitHub releases where you can grab the binaries, and that's how I choose to consume it. It was very straightforward to just write an Ansible playbook that reaches out, grabs the metrics logs, and traces MCPs and put them in my path. And if you're not using Victoria Metrics, there's a whole bunch of different MCP clients, and I'm pretty sure whatever observability tools you will be using have their own MCP servers. And then as far as MCP clients goes, there's a wide variety of clients that you can use with your MCP server. So if you're using VS Code or Cursor or the JetBrains IDEs, you can have it help you write code. I had a really good experience with the Z editor and GPT OSS, and there's also terminal tools like Warp, which try to wrap your command line experience and turn it into more of a AI agentic focused tool too. So the easiest way to get this set up in your client is going to be standard I/O, and what you will need to do is specify a name for the MCP server, the command you want to run, so like Docker run or the path to the binary, any arguments you need to apply for configuration, and then environments for things like secrets, or if you're using a self-hosted tool, you'll need to specify the URL. And then what this will look like inside of most tools is either it'll be a JSON file that looks like this, or it'll be inside of the GUI of your application, which renders down to a JSON file like this. And you can see whether you're using Claude, VS Code, Cursor, it's all pretty much the same. It's just you need to change like 1 or 2 lines of JSON and tab something over, and that was my experience playing with like 5 or 10 different MCP clients. And then once you configure the MCP tool inside of your client, you'll be able to either see in a list of available tools that you have, or if you're using something like Goose, you'll have to go inside of the settings, which I can show in the demo. And then if you need the list of configuration options, it's right in the README of the Victoria Metrics MCP or available at the QR code. And so there's 2 primary, along with standard I/O, which is going to have lower latency and have better security implications because it's just interacting over standard input and output on your shell. You can use HTTP. It will have higher latency and your threat surface is increased because now instead of just having to have local access to your machine, you have all the security fun of HTTP. There is something called SSE, but it's mostly deprecated, so you should pick between standard I/O and HTTP. And the primary time you would want to use the HTTP MCP transfer would be for things like a multi-user web browser experience where you can't feed it binaries to run or Docker or npx commands to run on behalf of you. And inside of the Victoria Metrics MCP, these are all the features you can have. So you can list what tenants are available in the system. If you're using the cluster version, you can get information about a specific metric or what label values are tied to a metric. You could ask it about alerts. So rather than having to go through like the VMUI page or Grafana where you have all hundreds of your alerts and you have to start searching and you kind of already know what you have to look for, you can ask it what alerts are firing in the environment and narrow it down from there, and it's much easier. You can also see what queries are currently running and which queries get run more frequently. You can construct logs, metrics, and trace queries just using plain English. So if you're not familiar with PromQL or you have users that don't want to learn PromQL or LogsQL, you can just ask it very simple questions like, tell me the request that had the highest latency over the last 24 hours. You could also ask it for statistics about like how often metric names are being used and what are the highest cardinality metrics in your environment. So that way, if you're trying to lower your observability costs, you can actually just ask an AI, hey, what are the highest cardinality metrics? Are any of these unused? And it will help you remove things, start you on your journey of removing things. And you could also use it to help you deal with retention filters and labels as well. And if you notice, most of those abstractions are, or most of those tools are just wrapping what's available in VMUI, but again, you get to interact with it in plain English rather than have to learn a tool or have to figure out how to expose this tool to your users. So it is demo time now. So this is Goose. This is the, do I need to zoom in anymore? Or is this good for everyone? Perfect. So this is Goose. We're going to try a live demo, but thankfully I have some pre-canned demos as well. So let's say I want to just see what alerts are firing in my environment. I just need to go and ask what alerts are firing right now. And then immediately I get developer. So we get to do live debugging now. So here's where you would go into settings for extensions. And you would be able to see I just had to set the bearer token for getting set up with Victoria Metrics. I think it might be a networking issue. Tree. Let's try that again. There we go. Live demos are fun. Thankfully, I do have chat history I could use. So here we can see, oh, come on. See all. So here I can check to see what alerts are firing inside of Victoria Metrics right now. It will run the tool call here, and something that's really nice is that we can actually see the output of the tool call. One of the things that delayed my adoption of AI was it would just hallucinate and make stuff up, but it wouldn't cite its sources. So if it did output something suspicious, I can now validate what happened, so I could actually see the JSON response here. Or if you're just doing like a normal chat workflow, you're allowed to have it see what links it researched on the internet. So here we can see we have an empty alerting and recording rule found, which are something I should look into later. I'm mostly focused on seeing the high disk utilization. And here it's telling me what the empty alert rules are for. So if I've never seen that before, I get a little bit of a summary. And I could also see that one of my kids' PCs has a full hard drive, probably because they don't install Steam games or uninstall Steam games. And then along with being able to get information about what I should do next, I'm also able to have it draw a graph inside of here as well to see if it's something that's increasing over time or decreasing over time. And if you're using Claude Desktop, it can draw way prettier graphs than this. This is just what I was able to render out with Goose. Another thing that happens too is we have requests that are really slow. So here I can go through and just ask it a very simple plain English question. Tell me about the caddy request with the highest latency. So because I asked it a question in plain English, it did have to go through a couple of tool calls to see like where the caddy logs were and then actually execute the query. And then here I get the individual fields for the caddy request. So what HTTP method it is, what the duration was, and what endpoint it was hitting. And I'm also able to see information about the encryption state as well. And another cool thing too, I didn't tell it at all that this server or this service or caddy was running a Matrix web server, but it was able to pick up on the fact that it was running on Matrix. So without any additional prompting, it figured out what the application it was running on. And then it also noticed that the payload was a little bit large as well, or a little bit larger as well. Another cool thing too is we can use this for signal correlation. So it did take me a couple of tries the first time I got an HTTP timeout, and I had to help it out a little bit. I had to go out of my way and find the trace ID for this, but I was able to find the trace ID at the bottom, thank you. I was able to find the trace ID here and then ask it, are there any traces tied to this request? It was able to use the Victoria Traces MCP to go through, find the list of services, query it, and then render out the duration for each individual request. So here we can see most of this was on the the parent request was handling the EDU, and I was able to go through here, read the detailed response that it generated, and then without even like asking it to troubleshoot the problem, it just generated why it thinks it was slower than normal. So here it could tell me that it was a issue most likely with the database. So before I even have to start remoting into the infrastructure, I have a good idea of what's going on. And then here we can ask it to explain itself more, and it will look into more of the context. Another nice thing too is if you're using Victoria Metrics Cloud, the MCP server also works with Victoria Metrics Cloud, and all those same tools will be available to you. And you, along with the tools that you would get for Victoria Metrics, you would also be able to get information about the Victoria Metrics Cloud deployment. So what alert rules did you upload to the cloud, what deployments you have, and what providers and regions you are running it. As far as roadmap goes, we want to work with the Alert Manager API. So if the way alerting works in Victoria Metrics is you feed rules to VM Alert, and then it will actually send the notifications out to Alert Manager, which has rules for silencing alerts if it's a no maintenance event, or inhibitions because some alerts depend on each other. So there might be something like an HTTP service is down that's not leading to another metric being generated. You really only care about the HTTP service being down and not the side effect of that. Another thing we would like to do is support metrics metadata, so that way you can get more reliable tool calls for things like I showed before with the Synapse server. Again, there's also an MCP server for Victoria logs. That is the list of different tools that it supports. And Another thing that you can do is use different models. So I didn't have a great experience using this on self-hosted models, but I also have one GPU with 16 gigabytes of RAM. I'm guessing if work would fund me having a giant box in my basement full of GPUs and using a 120 billion parameter model instead of a 20 billion parameter model, that would definitely help. Because as soon as I was like using the same setup and switched to like Claude or Grok, I had a way better experience. Also, different clients have different reliability with tool calls. So I would take the same like GPT OSS 20 billion parameter model. Some clients could get that model to reliably produce tool calls, even if it wasn't perfect with handling the response, or the context window would explode because the alert manager API wasn't paged. But other clients, it just wouldn't work. And you saw this a little bit with the caddy requests. Sometimes phrasing the request slightly differently would lead to better results as well. I don't have much else. Do you guys have any questions?
Any questions? Yeah, there.
Right there.
Do you have tools in place that would allow you to do like an ad hoc aggregation? So let's say you have you ask for a metric that you don't have on the, I guess, Victoria metric server. Would you be able to ask it, combine these two metrics, and would it like generate code to aggregate it, or how would that work?
Yes. So I did actually test that with logs. Instead of caddy, it was traffic. So I was able to say, find the highest latency request, and then it would actually generate that query out for me. So you can pretty much use it as a translator for like PromQL.
Any more questions? Yeah.
Good presentation, Matthias. Suppose if I have a container-based deployment for my MCP client and the host, my Victoria Matrix, it is in the different hosted server. With respect to authentication, is this the way only to using API-based authentication? Is there a way, any other alternate options available?
Yes. So I believe the question you're asking is, I don't have the ability to put the MCP binary on my machine, but I still want to use it?
Yeah.
Yes. So we actually have Helm charts for deploying the MCP server, and along with working in standard I/O, it works with streamable HTTP. So you can configure the MCP server to run in streamable HTTP, and then the MCP client would be able to interact with MCP tools over that HTTP protocol. It is slightly higher latency, but it's like 1 to 10 milliseconds versus 100 microseconds. Okay. And you also have to worry about securing an HTTP endpoint rather than standard I/O on your machine.
Okay. Okay. Thank you.
I just have a question, which is also a thing. Oh, not a question. It's for me, this MCPs for observability tools, like here Victoria Metrics, is very cool thing if you also work like Dan presented in a multi-agent setup, because now it's not me who has to mitigate something. I could now attach my Terraform, Pulumi, whatever agent to it, get the metrics out of it, and see what I have to change in my code, redeploy maybe to mitigate the error, or to change the stuff in my deployment, because yeah, now I have a feedback loop.
That is the next thing on my radar. I'm a little bit paranoid about like using the shell MCP where it just has access to whatever command line things I have in my environment. The way I want to test it is using an abstraction, so like HashiCorp Cloud for Terraform. I'm not sure what Pulumi has for this. I'm so sorry. Or like Ansible Semaphore, so that way I can say, if you notice a problem with like high disk space, you can run this playbook. So that way it has a more limited set of things that it can do, not only for security reasons, but for like, if it's cleaning up disk space, there's a chance that it runs rmtac/rf/. Whereas if you give it a playbook, it's like, these are safe things you can do to mitigate disk space.
Yeah, I can talk for the Pulumi one, the Pulumi MCP, because we have also an agent, has the ability to have agent as a tool. So you could now tell our agent, which is running on our system, to say, hey, I have this and this issues. The agent itself is heavily with the human in the loop. It will create a pull request you can then finally approve before you roll it out into production. So that's very cool. So yeah, that was just a question from my side. Any more questions? Because it's a really interesting topic, and everybody else missing out on this one. If not, we're going to continue at 2 p.m. So there will be 2 PMs, there is no break. And yeah, thanks, Matthias, and see you.